Okay, we are on page 30, page 30. Get your book out, turn to page 30. Anyone need a book? The blue book. Yes. I get the feeling you guys are as motivated as I am today, but I'm going to be motivated for you. Get your book out, turn to page 30. Let's go now. So the solubility product, is that the same as the solubility? No. Is it related to the solubility? Yes. Okay, so the smaller the KSP, the lower the solubility. Because the smaller the KSP, that means you have smaller ion concentration, yes? Therefore, less is dissolved. Now, it is somewhat difficult to make direct comparisons unless you have the same ion ratio. So, when you have the same ion ratio, either 1:1 or 2:1, you can make direct comparisons without actually having to do any math. Okay? So let's take a look at these three salts here. This first one, we could say it has the formula A2B. Yes? So we have a 2:1 ratio. In our second salt, we have A, B, 2, so we also have a 2:1 ratio. It doesn't matter whether it's 2:1 or 1:2. It all works out the same in the math. Okay, and this last one we have A, B, 2. So they all have a 2:1 ratio. So for all of them, let's just say I have A2B solid in equilibrium with A plus, 2A plus aqueous plus B 2 minus aqueous, and then my KSP will be, what's the KSP for this one? What's the KSP expression? A squared, A plus squared times B 2 minus. And if we don't know the concentrations, we can say a certain amount of A2B dissolves to give us a saturated solution. Yes? And we're going to call that amount X. If that amount dissolves, then what will the concentration of A be? Concentration of A will be, if this is X, yeah, it's going to be 2X. And how about the concentration of B? B will be X. So if we look at this and we plug those numbers in, then we have KSP is equal to 2X all squared times X. So far, so good? And then if we simplify that statement, we now have KSP is equal to 2 squared is 4, and X squared times X is X cubed. Is good? Okay. Now, we said that X was enough to give us a saturated solution, yes? The definition of solubility is the concentration of a saturated solution, yes? So enough to give us a saturated solution, that is the solubility. Okay, because solubility is the concentration of a saturated solution. That's the maximum amount that can dissolve. Yes.
Move your screen now, right?
Yes, I sure can. So in this case, what, yes, sorry.
Saturated solution.
What is a saturated solution? It means it has the maximum amount of dissolved solute. Okay? Let's write that down somewhere. A saturated solution contains the maximum dissolved solute. So basically, the concentration of saturated solution is the maximum concentration. Yes? And what have we defined as meaning concentration of a saturated solution? What have we defined as meaning solubility in our equation? We've defined X as solubility. So we're saying let X be the solubility, which is the concentration of a saturated solution. Yes? So if X is the solubility for any salt which has a ratio of 2 to 1, any salt where we have a 2 to 1 ratio, we're going to end up with 2X and X, or it could be the other way, it could be X and 2X, yes? But the math will work out the same. You'll still have 2X squared and X. So for any 2 to 1 compound, we end up with KSP is equal to 4X cubed. Is that true for all 2 to 1 ratio compounds? Yes.
Would it be true for all one-to-one ratio compound?
Nope. We'll figure out the formula for 1-to-1 ratio compounds. Okay, it's not going to be 4x cubed. Okay, we'll do 1-to-1 in a minute. Okay. 1 to 2, yeah, all 2 to 1 and 1 to 2. Sorry, yes, yes. Now I'm going to let you know if you are doing a multiple choice question and you are given the KSP and you need to solve for the solubility. And remember what is representing solubility here? X. If you are in a multiple choice question, if you are given KSP and you need to solve for X, the solubility, you can just use that formula. Okay? If you are given a written response question, you should be writing the, what do we call this formula here? That is the solubility equilibrium equation, or the SEE. Nobody calls it that except for me, so don't be writing SEE on the AP exam and expecting them to know what that is. I just got tired of writing solubility equilibrium equation. It was crazy, especially when it has such a nice little acronym like C. So if it is a written response question, you must write the C. You must write let X equal the solubility. And don't worry if this is...
We are now ready for the teachers from Assembly 1 to head down to the gym.
We're Assembly 3.
Announce the last name of the teachers for Assembly 1. Ashford, Bellion, Blazer, Ruder, Cameron, Corolla, Chapman, Chen, Dare, Ditfield, Kim, Mehta, Patel, Quinn, Richardson, Sastry, Severson, Sullivan, Vanderson, Williams, Sorry. Please make your way down to the gym now for your assembly.
I don't know. I feel like maybe they wanted like a mixture of seniors and juniors or something. I just don't know, but I'm just making that up. Okay. So if it is a written response question, you must write the solubility equilibrium equation. You must write let X equal solubility, and then you must show this little thing like underneath, so you know you've got a 2X to X ratio. You must write then the KSP expression, and then plug in the 2X and the X, and then get the 4X cubed. Does that make sense? So for a long response, for a written response question, you're going to write all of that stuff. Don't worry if it's a little bit cluttered here and you're like, I'm never going to remember that because it's all over the place. It is written down several places later on in a clearer fashion, okay? But multiple choice, feel free to go. This is a 2-to-1 compound. I know that KSP is equal to 4 times the solubility cubed. And you can then, if you're given the solubility, you can find the KSP really fast. And if you're given the KSP, you can find the solubility really quickly, okay? So let's take a look at our 3 KSPs for our 3 compounds here. We have 10 to the 12, 10 to the negative 12, 10 to the negative 6, 10 to the negative 16. Tell your partner which of these compounds has the highest solubility. Second one, yes? Yeah, it's got the biggest number. So if KSP is the biggest, that means that the ion concentrations are the biggest, which means it is the most dissolved. Ding. Yes. Which one is the smallest solubility? The third one, okay? Smallest number, okay? It's really straightforward. So you can just put them in a row like that. You can just compare them. Very straightforward. All right. This method of comparing KSP values only works for compounds with the same ion ratio. So you could compare compounds that have a 2-to-3 ratio, yes? 2-to-3 or 3-to-2. So you could compare all of those to each other based on their KSP. You could also compare 1-to-1 and 1-to-1. Don't forget that the CO3, the 3 does not refer to the number of carbonates. Okay, and 1-to-1. Doesn't matter the charge of the ions, it's still 1-to-1. Okay. What you could not compare is, say, AgCl, where you have 1-to-1, and then you have CaOH2, where you have 1-to-2, and Mn3PO4, where you have 3-to-2, because X will be different depending on the formula, yes? So let's just take a look at the KSP. No, we're just going to go back here. Let's just take Al2CO3. Al2CO3, 3. And we are going to let X equal the solubility of Al2CO3, 3. That L is looking a little weird there. What's the first thing you should do when you're figuring out how to rate how to solve for a solubility or solve for a KSP here? The C, yes, the solubility equilibrium equation. So we've got 2 Al3 plus 3 CO3 2 minus, and don't forget this one, because you're dealing with solids and aqueous, you should always be writing your states. Now, if X is the solubility, we have X. What is the concentration of 2Al3 plus? Or sorry, not of 2Al3 plus. What is the concentration of Al3 plus? 2X. And CO3 2 minus is 3X. If this was a written response question, what would you do next? KSP. KSP equals Al squared times CO3 2 minus cubed. KSP is equal to, and Al3 plus is 2X, and we're going to square it. And CO3 2 minus is 3X, and we're going to cube it. And so KSP for something like this is going to be 4 times 27, which I believe is 108. And the only reason I know that is because I have a question on a worksheet that has that number on it, and I've been using that worksheet for the last 28 years. So that's the reason I remember that number, not because I know what 4 times 28 is, or 29, 27. So 108x to the what? X to the 5. Is it worth memorizing that one? I don't think so. I don't think you're going to come across it that often, and it's easy enough just to throw the 2x squared in and the 3x cubed and figure out what the number is. Does that make sense? Now, what if we have a 1-to-1 ratio? We're going to have AgCl in equilibrium with Ag plus, Cl minus, solid, aqueous, aqueous. Let X equal the solubility of AgCl. We have X, we have X, we have X. KSP then equals Ag plus times Cl minus equals X squared. Whoops. Oy vey. So I would know this one because this is really easy for multiple choice, and I would know the 4x cubed because that's easy for multiple choice. I would not bother stuffing 108x to the 5th in my brain because I could just as easily solve it as bothering to memorize it. Yes? If you have 28 years to memorize that, then you go for it because it does work after 28 years, but you know. No! Blank screen for the first part. So sorry, people who aren't here. Maybe if I'm really clever, I will re-record the first part of the lesson tomorrow. Yeah, because that sucks. If anyone is really familiar with using OBS, you could come give me a little tutorial, because last time it just set itself up nicely and just started doing things the way I wanted them. And I was like, great, that's fantastic. This time it is not automatically doing what I want it to do. I have to keep clicking on things. And I'm like, why? Last time I did not have to click on things. Why has it changed this time? Anyway, over the weekend, I will see what I can do about figuring it out so that we don't have to. Okay, nothing here that's new. 3.2b, saturated and unsaturated solutions. So this is now page 33. And in fact, you know what I'm going to do? I'm just going to start